Today we're going to be doing 7.3 triangle similarity. AA, SSS, and SAS. Alright, we're going to jump right in and start off with the postulates. Okay, this is to prove that triangles are similar or to find out if they are. Alright, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So say in this case A and D would be congruent and B and E would be congruent, therefore they are similar. That was pretty simple. It goes under the name of AA, angle, angle, and yeah, it's just a matter of remembering it. Alright, give you a second just to take that in. Alright, now we have side, side, side similarity. If three sides of one triangle are proportional to three corresponding sides of another triangle, then the triangles are similar. So if AC and DF are proportionate, and ED and BA and BC and EF are all on the same proportion, so they're not just randomly bigger, then the triangle will be similar. So they all have to have the same proportion of increase or decrease between the two triangles for them to be similar. Okay? Simple enough? Alright, and the last okay, this is a theorem. The next theorem. Side, angle, side similarity theorem. If two sides of one triangle are proportional, so we'll say these two are proportional, of another triangle, and their included angles are congruent, so this angle and that angle, then the triangles are similar. Alright, this one is SAS, you can remember that one. So it's two sides are proportional, so E and D and BA would be proportional, and BC and EF are proportional, and then those angles, so E and B, in these triangles, they're congruent, then the triangle is similar. So it's two proportionate sides and a congruent angle. Alright? Just making sure we didn't miss anything. Load. Alright. There's properties of similarity, just to note. The reflexive property of similarity is pretty straightforward. Triangle ABC is similar to triangle ABC. You know, just same triangle equals same triangle. Symmetric property of similarity. So if ABC is similar to DEF, then DEF is similar to ABC. It's just reversed. It's also pretty straightforward. It's called the symmetric property here. And the transitive property of similarity. It's just like the transitive property of pretty much everything else. If ABC is similar to DEF, and DEF is similar to XYZ, then ABC is similar to XYZ. So it's just the transitive property as applied to similar triangles. Alright, now that we have the basics down with that, let's try some practice problems. Alright, some practice problems. We'll start with practice problem 1, because you know what, 1 is a good number. Okay, we have two triangles here, and we need to prove that they are similar. Alright? And explain why. So, we know that this angle is equal to 52, and this angle is equal to 52, because they tell us. Well, since they are both equal to 52, we know that at least one angle of this triangle are congruent. So for us to use AA to prove that these are similar triangles, we need to know that either angle A is equal to 47 or angle G is equal to 81. So we're going to try to find the measure of angle A and see if it equals 47. Alright? So we're going to use our handy dandy whiteboard and do some math. Alright? So now we have 52 plus 81. And since we know that triangles have to equal 180, all of their angles have to equal 180, we're going to add these up and then subtract them from 180 to find the remaining angle. So this is going to be 133, right? Now we have our 180. We're going to subtract 133 from 180. Pardon my handwriting. This is harder to write on than the old smartboard marker. All right, so do some mental math here. We have 7, 47. All right, we get the remaining angle is equal to 47. So we know that angle A is equal to 47, angle F is equal to 47, and these angles are congruent. So now we know, using AA, angle-angle postulate, that these two triangles are indeed similar. All right? So now I need to write a similarity statement. So a similarity statement is simply just stating that these are similar. So it would be CAB is similar to HFG. All right? We're just going to write that down. CAB is similar to HFG. Okay? Again, pardon my handwriting. Alright, so we're just going to clear this. And we're going to look at another example. Alright? Alright, let's do number 5. That looks like a good one. Alright? Explain why the triangles are similar, and then find each length. Okay? So we need to find the length AB. So this length right here. Alright? Alright, so like I said, we need to find the length AB. Alright, because we know that angle E and angle C are congruent, we're going to go with the side angle side theorem to prove this. And so we're going to set up a proportion. We're going to start with 9 over 6, okay? Put 9 over 6. I already set it up, so I'm going to explain why I did it. We have 9 over 6, and then we're going to have 15, because that's this side, over 6 plus x, because we're doing the whole triangle side. It's not just this little section, we're doing the whole triangle side. Alright? So now I just need to solve this. So let me pull up my calculator, and we're going to do 6 times 15. 6 times 15 equals 90. So on one side we have 90 equals, okay, now we're going to do 9 times 6, that equals 54, so now we have 54 plus 9x, because we have to distribute the 9 between these, distribute the 9, alright? So now we subtract 54 from 90. I'm just going to do it in my calculator real fast because it's a little bit faster. So we get 36. 36 equals 9x, and divide the whole thing by 9 to get x. And x is the length of AB that we're looking for because of how we set up the equation, and we get 4. X equals 4. Alright? So now we know that the length of, okay, x was the length of DB. The answer is the length of 6 plus x. So it's 6 plus 4, that equals 10. Equals 10. AB is equal to 10. And we know that these triangles are similar because of side, angle, side, because we proved that through a proportion. Alright? Goody. Alright. Now let's do a proof. See if we can do one of those. Alright, we'll do number 7. Alright. Let's start with the given. The given is MN is parallel to KL. Alright, and we're looking to prove that JMN is similar to JKL. Alright? So, we know that the MN and KL is parallel, so that will be the given. Alright, that's our given. If you're writing this down as we go. So, because of what we know about parallel lines, we know that angle K is congruent to angle M because of the corresponding angles property. Alright? Because they're corresponding angles, we know that they are congruent. So now we have one angle. Alright? We also, by the same property, corresponding angles, know that angle L and angle N are corresponding, okay? Because corresponding and therefore congruent. So we know that K and M are congruent and L and N are congruent. All right? Therefore, because of AA, because we know that two sets of angles are congruent, we know that this third angle is congruent, and through AA, we can say that JMN is similar to JKL. Alright? This one was pretty simple, but it revolves around AA and what you know about parallel lines, which is probably going to show up more in the future. Alright guys, thank you so much for listening to me talk about math. And I hope I answered some of your questions. I hope you understand how to use these properties and these postulates and these theorems. And if you have any more questions, ask me in person or shoot me a Moodle message. I'll be happy to explain it a little bit further. Alright, I guess that's it, guys. Bye!